So solve this question number 15. This is JEE Main 2013 question. So solve this question. Are you trying it? If okay. It it says a circular loop of radius 0.3 centimeter parallel to a much bigger lies parallel to a much bigger circular loop of radius 20 centimeter. So there are two circular loop. Suppose this one is one circular loop and there is another circular loop, both lying parallel to each other. So and it says that their center coincide. So their centers coincide and the center of the smaller loop lie on the axis of the bigger loop. Okay. Distance between their centers is 15 centimeters. So this distance is given 15 centimeter. If a current of 2 ampere flows through the smaller loop, there is a current of 2 ampere through the smaller loop. Then flux link with the, we have to find magnetic flux link with this bigger loop. So to find the magnetic flux link with the loop, we must have to find magnetic field there. And so to find the flux through this loop, we will find magnetic field and then we will apply by area. This is a small loop, so magnetic field will be along the axial line. Magnetic field is always along the axis of a circular loop. So and so we have to find that. And okay, so how we can find magnetic field due to the smaller loop? We can find B is equal to, you know that magnetic field due to a current carrying coil is mu naught Ni A square upon R square plus A square 3 by 2, or we can say that x square plus A square 3 by 2. So A is the radius. You know this formula, magnetic field on the axis of a current carrying loop. I think we have discussed this formula also. You know this formula, magnetic field on the axis of a current loop, mu naught Ni A square by 2 R square plus X square plus A by 3. You know this formula, refer. We have discussed it also. All right. So now it is given that the loop is very small, right? So you can neglect A, since A is much less than X. Here X is equal to 15 and A is equal to 0.3. So A is much less than X. So X square plus A square will be almost equal to A square. So the magnetic field will be almost equal to mu naught Ni A square divided by, there is also 2, so 2 A square power 3 by 2. So we will get it as mu naught Ni A square Ni A square upon 2A cube. So we will get it as mu naught Ni by 2A. And also we know that number of loop is 1, so N will be also will be 1. So the magnetic field will be mu naught I by 2A. So we'll put the value. Mu naught, we know that 4 pi into 10 to the power minus 7, and I is given as 2 ampere, and 2 radius is given as 0.3 into 10 to the power minus 2. So the magnetic field will be around 2 pi, that is 4 pi. Magnetic field will be around 4 pi by 3 into 10 to the power minus 4. 10 to the, it will be magnetic field. Now we have to apply by area. So flux through larger loop, we will get it as phi equal to B into A. So B we got 4 pi by 3 into 10 to the power minus 4 into area of larger loop will be pi into R square. So we will get it as 4 pi by 3 to 10 to the power minus 4 into pi, and radius of the larger, what is the radius of the larger loop? 20 centimeter. So it is 20 into 10 to the power minus 2 square. So we will get it as 4 pi by 3 to 10 to the power minus 4 into pi into 4 into 10 to the power minus 2. So we will get it as 16 pi square by 3, 16 pi square by 3 to 10 to the power minus 6. And pi square, you always remember pi square is almost equal to 10. You can put that value 16 into 10 by 3 to 10 to the power minus 6. So we'll get it as approximately 16 by 3 into 10 to the power minus 5. So 5 point something, 5.33 into 10 to the power minus 5. So 5.3 into 10 to the power minus 5. Is there any mistake? Please check calculation. In the magnetic field we got mu naught in I by 2a, 2, sorry. There is a mistake. Here x square, x is much greater than a, right? So x square plus a square should be equal to x square, not a square. It should be x square, right? Getting my point? X is greater, na? So that is why here we will get x. Here we will get x, and x is 15 into 10 to the power minus 2. So 15 into 10 to the power minus 2. That will also change. Here it will change. Here it will change. So we will get it as so it will be 4 pi by 15 into 10 to the power minus 5. 4 pi by 15 into 10 to the power minus 5. So here into 10 to the power minus 5, 15 minus 5. So we will get it as 4 by 15 into 10 to the power minus 5. And so we will get as 4 pi 16 pi square by 15 and 10 to the power minus 7. 10 to the power minus 7. So, and pi square approximately 10, so 10, so it will be 16 into 10 by 15 into 10 to the power minus 7. So we'll get it as 16 by 15 into 10 to the power minus 6. So approximately 1 point 1.06 something into 10 to the power minus 6 kind of thing. Why don't we are getting again? There is a calculation. Please check calculation. So 4 pi by 15 into 10 to the power minus 5. Mu naught I by 2x. So again there is a mistake. Let me do it again. Since here we have a square and aq, right? So in place of aq now we got xq, right? We got xq. So it will be a square by xq in the expression. We have cut a power of 1. Power of a has been reduced, so it will remain in the numerator, right? Because we have taken a in the denominator, that was power of a has been reduced. So now the expression for magnetic field will be mu naught n I a square by 2 xq, right? This will be the expression for magnetic field. Getting my point? So flux will be, so now we can calculate we can put directly flux phi will be b into a, so mu naught n I a square by 2xq into, we can put the area, so area is pi into radius 20 into 10 to the power minus 2 square. This we will get. So now putting the values, 4 pi into 10 to the power minus 7 into, current is 2 ampere, radius of the smaller loop is, what is the radius of the smaller loop? 0.3 centimeter. 0.3 centimeter. So 0.3 into 10 to the power minus 2 square divided by 2 into 15 into 10 to the power minus 2 square into pi into 4 into 10 to the power minus 2. Now we will get the answer. So it will be 4 pi square into 8 into 9 to 10 to the power minus 7 minus 6 minus 2 and 4 into 8 into 9 pi square divided by 2 into x is cube. So 2 into 15 into 15 into 15 into 10 to the power minus 6. So now 4 into 72 into 10 to the power minus pi square, we will take it as 10. So minus 40 and divided by 2 into 225 into 15 to 10 to the power minus 6. So now we can calculate it. 288 by 225 into 30 into 10 to the power minus 8. So we put the approx value, we can put it, and 96 divided by 225 into 10 to the power minus 9. So 96 by 225 into 10 to the power minus 9, or 96 by 225 into 10 to the power minus 9. So we can put it 960 by 225 to 10 to the power minus 10. So approximately 4 into 10 to the power minus 10. Approximately less than 4, like 3 point something kind of thing we should get. 3 point this into 10 to the power minus 11. Geez, 225. It is divided. Divide 960 by 225. How much we are getting? 960 divided by 225. We are getting 4.26. 4.26 to 10 to the power minus 10. So which one is the closest option? 4.26 into 10 to the power minus 10. So the process is same. You again check your calculation. Maybe the process is same. You may have some calculation. You have to check it correctly. So you will get in the answer. Getting my point? So have we taken 2 also in the denominator? So I will not take more time in this. So try yourself by calculation, right? Refer. The process is same. You will get the answer. Write the expression of magnetic field, and you solve yourself again. You will get the answer. All right. Moving to the next question. So this are based on question based on the process is same. We have to find the magnetic field and then flux. So it's little bit lengthy question. Such question should not be attempted in the exam. Try to attempt. These questions are basically given to trap students. So such kind of question you mostly try in the attempt at the last if you have time. Otherwise leave such question. It will consume lots of your time because it requires calculation, right? So we have to be very careful. Now moving to the next topic, we have discussed flux, then Faraday's law. query the Faraday's law of electromagnetic induction or Faraday's law of induction. There are two laws. First law, there are basically now we, Faraday did an experiment, and what he found that when there is a change in magnetic flux through a coil, there is induced EMF. Whenever there is a magnetic flux changing with a coil, there is always an induced EMF. So, in the first law, he says that when phi changes, EMF induces. In first law, he says that when phi changes, EMF induced. Right. Now, in second law, he gives the expression of that induced EMF, which is minus d phi by dt. Rate of change of magnetic flux gives EMF induced in the coil. So this was the second law, and negative sign is due to Lenz's law, which we will study. Lenz law, I think you are familiar with what Lenz's law says. Lenz's law says that so Faraday gave two law. First, he says whenever there is a magnetic flux, change in magnetic flux associated with the coil, then EMF is induced. And in the second law, he has given the expression for magnetic induced EMF, that is E is equal to minus d phi by dt. Here minus sign indicates the EMF induced is always opposes the change which has caused it, which we will study further in the Lenz law. So that is why here we are giving the negative sign. So let us first do some questions based on Faraday's law. Then we will discuss Lenz law, and we will do this some question. So do you have any doubt regarding Faraday's law? I think you should not have any doubt regarding Faraday's. That is very basic. So concept will come from doing questions only. There is nothing in the law, only expression is there. So let us do the questions first. So to do this question number 7, is based on, this is NEET 2012 question. To attempt this one. Yes, we have to use I is equal to E by R. So we got answer as A. A is the correct answer. So yes, we have to do that. E is equal to d phi by dt, right? So EMF will be equal to d phi by dt. You have to differentiate it. 15 t square plus 4. So we'll get it as 100 t, right? So at t is equal to 2 seconds, we will get EMF as 200 volt. So current will be E by R. So 200 by 400.5 ampere. Understood? So this is how we should solve the question based on that. All right. Let us do one more question based on that, then NEET question. Do this question number 8. Attempt the question number 8. Are you trying it? Hmm. So let us see. In this, in a coil, the question says in a coil of resistance 10 ohm, the induced current developed by the changing magnetic flux through it is shown in the figure as a function of time. So current induced in the coil is given in the I versus T graph. Then magnitude of the change in flux through the coil. So we have to find the magnitude of change in flux through the coil. So for that, so I will give you two methods to solve such a question. Uh, Method 1, we know that I is equal to E by R, and we also know that E is equal to d phi by dt, right? R. Also we know that I is equal to dq by dt, so that is d phi by dt into R. So dt will be cancel out. So from here we can write d phi is equal to d phi is equal to R into dq, right? Or we can say change in flux delta phi is equal to delta q into R. So this relation is very important. You can directly remember this. You can directly remember this delta q is equal to delta phi by R. This will be very useful. Now you can find delta q from this. We know that I is equal to delta q by delta t. So area of IT curve will be give delta q. How you can calculate delta q? Area of IT curve, right? IT graph will give delta q. Getting my point? So calculate it. I have given you the hint. You calculate delta q, multiply by R, you will get the answer. Understood it? So solve it. Are you solving it? Have you calculated dt delta q? If you able to find delta q, then you will find. Yes, B is the correct answer. So B will be correct. Delta q will be directly we can find by area. So delta q will be half into 0.1 into 4. It means it will be 0.2. So multiply by it. You get 0.2 into R is 10. You get 2. Correct answer is B. Okay. So the best part is always remember this. Delta q is equal to delta 5. I was going to give method 2 by directly using this. So you have to remember this. It will be every time you don't need to derive delta q is delta 5 by r. You remember this. It will be very useful. So now moving to the next question. This is also very important question. Solve question number 9. Solve this question number 9. So I will give you a hint. It says that the variation of current in a coil varies with time is shown in the figure, then variation of induced EMF. So what you have to do is, it seems to be difficult, but it is very easy. Why we have to apply E is equal to d phi by dt. Not directly you can write. So the variation of current in the coil is, and phi is also proportional to I. We will see that flux is proportional to current. So directly you can write EMF is directly proportional to di by dt. That is the thing. We know the formula, right? We know the self-inductance of a coil. We know formula phi is equal to Li, right? So we know that phi is proportional to I. So you can say that EMF is directly proportional to di by dt, and from that you can find the correct graph. Understood? So you got answer as D. Yes, I think D is the correct answer. Understood how we got? But we check option A also. E is equal to minus d phi by dt, right? Opposite of that. So the correct answer should be A, right? You got only, you have considered only magnitude. If you see the options, if you see options A and D, both are similar. But if we know that EMF is minus di by dt, right? Getting my point? So it should be A. Yeah. This All right, let us do some JEE questions based on that. Then we will move to the next topic. So this is a very important topic. Can you solve this question number 1? Try it. Question number 1. This is JEE Main 2020 question. Try question number 1. Try this question. Can you see the question? Question number 1. Right. So let us see. The question says that let's check its answer first. Question number one. Yes, I think answer is B. Your answer is correct. So let us see first. The question says that a small bar magnet is moved through a coil at constant speed from one end to the other end. Which of the following series of observations will be seen on the galvanometer attached across the coil? The positions shown describe one the magnetic entry to the completely inside and thin magnetic. So the flux. So it is clear that flux will be the main concept is magnetic flux is changing. So EMF will be induced when magnetic flux changes. So magnetic flux will be induced at two positions, right? At the entry point and at the exit point. Here phi is almost constant. Phi is constant, so EMF will be 0. No EMF induced. When it is in the middle, when it is entering, flux increases, so EMF will be induced, and when it is outgoing, flux decreases, so EMF will be induced, and both should be in opposite direction. If it is positive, it should be negative. So now you can see A is not possible, B is also not possible. Here showing flux is induced in the middle. So here also uh, indicator is changing, so this is also not possible. So the correct answer is B. Understood? So 1 and 3 should be in the deflection should be opposite, and the middle portion remain as it is. Getting my point? So the correct answer is B. Got it? All right. So this is JEE 2020 question. Now try question number 2. This is also JEE 2020 question. Try second question. I will give you hint. I'm giving you a hint. One is that you take area of an ellipse as pi into AB, right? You take area of ellipse as pi into AB, and the second hint is it is EMF induced will be BA cos theta, yani BA cos omega t. EMF induced will be that. EMF induces, sorry, flux, not EMF. Flux is that. Pi is equal to, we know that BA. So here theta will be omega t, right? So flux at any time will be BA cos omega t. Now it's up. Now it's over to you. Solve it. I have given a sufficient hint. You can solve it easily. Understood the hint? Okay, solve it. Here you have to find power, right? So first you will calculate EMF from d phi by dt. Then power is V square by R. Then you have to calculate average value of that. So we got it as A. Let us see. So what we have to do? First we will calculate phi. Phi is BA cos omega t. Then we will calculate EMF. EMF is d phi by dt. We'll get it as BA. What is area? Area we will put in later. And d by dt of cos omega t. We'll get it as BA cos of sin omega t and into omega. We are only putting magnitude. So it will be BA omega sin omega. Now I is equal to E by R, or also we can say no need to calculate current. Resistance is not given, right? So resistance is given, no doubt. So now you can calculate power. We know that power through coil is E square by R. So it will be B square A square omega square sin square omega t by R. Now we'll put the value of area. So it is pi square A square B square and again B square omega square by R into sin square omega t. Sin square omega t. Now we have to calculate average power, right? So average power will be, all the terms are constant, pi square A square B square B square omega square by R, and we have to take average value of sin square omega t. What is the average value of sin square omega t? What is the value of sin, average value of sin square omega t? Because what is the average value of sin square omega t? Your math student, right? You should know that. Yes, it is half. So we have to put half. So it is half pi square A square B square omega square by 2R. So yes, option A is the correct one. Understood? So this is how we should proceed for question based on magnetic flux. Now let us see where I can solve some easy questions. Can you solve question number 13 quickly? Question number 13. Solve question number 13. Solve question number 13 quickly. For 13, what you have to do? You have to apply the formula. You know that phi is equal to Li. So d phi by dt is equal to L into di by dt, right? So EMF will be equal to L into di by dt. So EMF is given, and what is the value of EMF? It is given as 50. L we have to calculate, and di by dt is 3 by 0.1, right? So we'll get it will L we have to calculate. So 10 upon 3. How much you got? D, right? Yes. Is it D? 10 upon EMF is given as 50 and DI is 2 ampere in 0.1. 5 to 2, 3 ampere divided by 0.1, right? 3 ampere by 0.1. The time is 0.1. So it will be 5 upon 3. Correct. Correct answer is D. Understood? So this is all for today's class. Any doubt till now? All right. So I'm ending with this today's class. We will discuss more in the coming class. All right. Thank you.